This conference will now be recorded.
Okay. Okay, just a moment. All right. Let me just give me a moment. I'll share you the YouTube link also so that you're in a position to access it without any difficulty. Okay, right. It's here. Okay. Okay, this is what it is. So the concept of reliability and validity, I have captured it in the form of YouTube. Okay, you can have a look at it. All right. So you can also subscribe to my channel and you can give your comments or likes or dislikes, whatever it is. So I have shared the YouTube link in the chat window. You can bookmark it because I have discussed one or two techniques which I feel a researcher needs to know. So it will be a good refresher for those people who wanted to refresh. I understand that you may not be able to remember whatever we are discussing it in our session because we may be having our own personal works. So these type of videos you can bookmark it in your browser and where you may need it. Okay, it may not be now, but whenever you're doing analysis, you may need it. That time you can take it as a refresher because already we have covered this concept. Right. So with this note, okay, we will enter into the day 4 session. So day 4 session, the agenda today is that we are going to focus exclusively on regression. Right. So why I'm telling you because correlation and regression, that is the base for many of the statistical analysis. Right. So may I know that who are all using SPSS along with me? At least if at all, will you be in a position to raise your hand? Because so that in that way I'll be able to at least ask one or two questions and get to know about whether they are able to understand. I don't have any problem if you're listening via mobile also, but make it a point that you can get the recording of it so that whenever you need it, you can refresh it. Right. So today I'm going to use the regression. I'm not going to use the data which I'm having right now. I'm going to have the data which I'm going to download it from internet. Okay, the data is what we call it as Nifty. Okay, we all know that stock market and all those things. Now people, they invest their money in stock market based on various parameters, and now I'm going to pull out the data from Nifty, okay, which is the representation of 50 actively traded companies in India. I'm going to take out at least the last 1 month data and try to see that what are all the factors which determines the Nifty. Okay, especially is it going to be yesterday's opening price or yesterday's closing price, what exactly? So for that purpose, I'm opening this browser, okay, and I'm searching Nifty historical index, Nifty historical data, Nifty historical data. So when I do a search like this, today you can see that the stock market has taken a big rally today. Okay, now go to the first link. Go to the first link, right? So you can see that the index, that is Nifty 50, which you can select it. And I'm interested in downloading the 1 month data of Nifty 50 and try analyzing it. What is the information that the Nifty 50 says for me? So today is what? Today is 17th. Okay, so I'll take out, all right, 22. Okay, 22 is 17. So I'll take out from Feb 16th, Feb 16th to yesterday. Okay, so I'm just, are you all with me? Are you all with me? Are you in the same page where I'm also present? I'm not going to use the data for which you have already taken up the survey. I'm taking the historical data of Nifty 50. Are you all with me? Anybody is having any doubt? Okay, so once you have chosen this, click on get data. Okay, so once you have clicked on this data, scroll down, Okay, scroll down. Okay, there you'll find an option called download file in CSV format. Now I'm going to download this. Click on download file in CSV format. All right. So double click on this data. Double click on this data. Okay. So now I'm opening the data in the form of CSV, that is in Excel format. Okay. Now here you can see the date. Okay. And the opening price, closing price, how much amount of shares it is being traded. So able to see this. Now here I'm going to take out the data which I wanted to analyze. So basically I'm interested in predicting based on what data that the next day stock price is opening. Say for example, if you look at this February 16th, the opening price of the stock was 17,408. It went up to 17,490 and it came down 17,257 and it closed at 17,322, right? And the very next day it opened at 17. So this is what this data all about. So it basically talks about the stock fluctuation on each and every day basis. Right. Now I wanted to find out whether this next day opening price, okay, next day opening price is been affected by the previous day closing price and opening price. So for that, I'm opening a new file here. Okay, I'm pasting this. This is next day opening price. Okay, I can name it as Y. Okay, I can name it as Y. And then I'm also interested in finding it out the previous day closing price. Previous day closing price. Previous day closing price. Okay, that is previous day closing price, which is X1. Then I'm also interested in checking out whether the previous day opening price is affecting the next day opening price. So that also I am pasting. Previous day opening price. Okay, previous day opening price. It is X2. Right. So this is what this data is all about. So this data, you can delete the last two rows, because point to be noted is that when you're copy pasting the independent variable, that is X1, X2, I mean the previous day closing price and previous day opening price, it should start, you have to take out the complete one starting from 16th Feb. Okay. But when it comes to next day, you should select the data only from 17th Feb. That is where you'll be able to find out is the impact of previous day price fluctuation is happening on the next day price fluctuation, right? So now I will be saving this data in the form of Excel, and I'll open this data using SPSS for analysis purpose. Now, okay, now training job Nifty 50 data, and today is 17th March. Okay, Nifty 50 data. All right, so this I have saved it. Now, is there a way that I can share this data to you? Any? I'm just checking. Is there a way that I can share? No. All right. Now here, I'm just bolding it. Now I'm going to import this data in SPSS. How do we do that? Now for that, I'm opening a new file. I'm opening a new file. Okay, I'm choosing Excel because I have saved in the form of Excel. So now you can see this is the data, Nifty 50 data 17th March. Open this file. I would like to check this option, that is read variable names from the first row of the data. All right, so click on OK so that I'll be able to see the names of the variable also, which is present on the first row. Okay, right. So now this is the data what I have got right now. Okay, so I will use it for this. I will, okay, this also I will save this file first. Let me save it in the path. So Nifty 50 data 17th March regression. So I'm going to perform this test called regression. All right. Okay. So I have used this data. I have downloaded this data. This is the actual live data. Okay, x1, x2, and y. These are all some of the notations what I have put. So before I am going to discuss about how do we have to analyze this data, I'm going to tell you about what is the meaning of the term regression. Okay, and then we'll get into the data. So for that, I'll open my PPT. Okay, so I hope you are able to see the file which I am viewing. Are you able to see the screen? Are you able to see the blue colored screen? Yes. Okay.
Yes, sir.
Now,
Yes, sir.
yes. Okay. Now, this is the understanding which we need to have first. What is the understanding is that, first of all, this is the line for the regression. So regression is basically all about, we are actually studying the impact of independent variable on dependent variable. Okay. And when we are studying the impact of one independent variable on a dependent variable, we call it a simple linear regression. And when we are studying the impact of two or more independent variable on the dependent variable, we call it as a multiple linear regression. And now this is the normal way of representing the linear regression in the form of equation, where y represents the dependent variable and x represents the independent variable. And the usual example which we can see is that, like, job satisfaction. Job satisfaction, if we consider y could be a dependent variable, and this job satisfaction is affected by salary, and salary can be considered as an independent variable. Of course, it is not just only the salary. There may be other independent variables also, say recognition, okay, work-life balance. So all those are different independent variables. So this job satisfaction, okay, which is actually a dependent variable, we are able to actually predict the job satisfaction if we have more number of independent variables. Right now we have only one independent variable, which is nothing but the salary. So we can't say that salary alone determines the job satisfaction. There are several other independent variables which determines the job satisfaction. So let's say that salary may be responsible for 50% of the job satisfaction. What about job surety? And what about something like good colleagues in the organization? All those things are equally important. So that means more the number of independent variables which is related to job satisfaction, the job satisfaction prediction will be very, very high. That means that we will be able to accurately predict. This is what the components of job satisfaction is all about, right? In spite of all those things, in spite of all those predicting power, there are a few variables which cannot be captured. Okay, that is what we call it as error term. Okay, I'll explain it further as we go deep into the analysis purpose. So what is this error is basically, we call it as an error or residual, is that I told you that the predictive power of y will be very high when we are adding more number of independent variables which is related to the dependent variable. Of course, even if you have 100 independent variables also, still certain variables has to be added. We can't 100% predict. We can't predict 100%. So that is what we call it as residual error. Let us say, for example, here I have told you an example of job satisfaction. We can take another example of, okay, let's say somebody's intelligence level. So let's say if I talk about a person who's getting into IIM, okay, basically they are considering three important factors. We call it as three important independent variables. One is their CAT score, another one is their group discussion score, and third one is their group discussion and the interview. But these three components alone will not determine somebody's managerial intelligence. There may be some other variables which may be there, which might not has been captured. Okay, that is what we call it as error term, and this error occurs because of so many reasons. It may be because of random error, so many reasons. Okay, something which is not being captured, okay, which is not being explained is what we call it as error. We call it as residual error or error terms. So many names we use it. And this one, okay, that beta naught is what we call it as intercept. Okay, this is about the intercept, and this beta 1 is basically the slope. We call it as a coefficient. Okay, if it is in the form of standardized coefficient, if this is what we call as covariance. If this covariance is in the form of standardized covariance, we call it as a coefficient, or call it as a beta value. Then x is the independent variable. So basically we have to know all these related terms. Y is a dependent variable, and beta 0 is basically an intercept. You can have your own symbol also. People, they use C or A, whatever it is. And this beta 1 is nothing but the slope or coefficient, okay, or the beta value, okay, any term you can use it. X is the independent variable, and this E is the error term. Okay, we can use E or we can use R for residual error, but the concept is very much important, right? So now this understanding that we need to have how a linear regression is formed. What are all the various factors which affects the dependent variable? What are the various factors? Dependent variable is affected by the independent variable, residual errors, the slope of the independent variable, and the intercept. All those things affects the dependent variable. Right. Now, then let us get into the assumptions of this linear regression assumptions. Basically, in linear regression, we do have some 5 different kind of assumptions, and we will be performing the linear regression only if our data fulfills these assumptions. And understand, in case if the linear regression is not fulfilling any of these assumptions, then probably we may not use linear regression. There is nothing like non-parametric regression what we have. Okay, right. First and foremost thing is that the model should be linear. So that means when we are considering two variables, let's say in case of simple linear regression, and when we are considering two variables like height and weight. So this height and weight should be linearly related. That means whenever height increases, the weight also should increase, or whenever height decreases, weight also should decrease. Okay, there has to be some linear relationship between x and y. That means between independent variable and dependent variable. This should be the first condition of linear regression assumption. I hope you have got what I'm trying to convey. Second assumption is that it should be normal. Now, point to be noted is that I have used this term normal in correlation also, but there I have told you the normality of variables, normality of x and y, normality of height and weight, and we have tested using SPSS testing also. Here I am talking about normality of residuals. What do you mean by normality of residuals? This is what I call it as normality of this residual. This residual is there, right? So that residual, that error term, there will be error term for each and every independent variable, and that has to be normal. Okay, so whenever you're plotting the there's a graph in the form of normal PP plot, you will be able to figure out whether the data is normal or not. That means the normality of the residuals we will be able to figure out through this normal PP plot, or you can go with a very accurate technique called Shapiro's will test using SPSS. Linearity of the model, you can prove that using scatter plot by just plotting, x and y on both the axes. All right. And the third one is, okay, now, I mean, have you all got what is meant by normality of residuals? Anybody is having any doubt? Anybody is having any doubt on the assumptions of linear regression? Okay. The third one is homoscedasticity. What is the meaning of this term homoscedasticity? Is that is the variance of error term or similar across the values of the independent variable, right? So I have told you about the error term. Okay, here also the error term comes into picture. So this error term will be for each and every independent variables. Okay, and this error term will be there for each and every independent variable. Okay, are you able to see the screen? Are you able to see the screen? Suddenly I'm not able to. Okay, okay, fine. Yeah. So this homoscedasticity, what it is, the variance of error terms are similar across the values of independent variable. So what exactly is this? So when we are plotting a graph between the residuals, okay, and the predictor, that means y and x, okay, the residuals, we will be getting certain error terms, and this error term should have the common variance. That means the variance of the error term across the independent variable should be constant. So I will tell you how do we have to test it using SPSS. That time we will get more clarity on it. We will be using this scatter plot to show how the variance of the error term is constant, right? So this is what we call it as homoscedasticity. It actually captures the variance of error term. If the variance of error term is same across the independent variable, we call it as homoscedasticity. If the variance of error term is not same, that means few independent variables are having some other variance of error term, another few independent variables are having some other variance of error term, which indicate that homoscedasticity assumption is violated. We call it as a heteroscedasticity. In fact, we can visually inspect whether there is homoscedasticity or is it heteroscedastic using scatter plot, which I will do that in SPSS. And fourth assumption is multicollinearity. What is this multicollinearity? Multicollinearity is basically the independent variables at times, they are interrelated with each other. Of course, when you're designing the construct, okay, I have told you the concept of construct. We will be asking many questions to capture a particular construct. So at times what happens is that the questions are interrelated with each other, wherein the response what you're getting from the respondent, they tend to have a same response. Say for example, let's say that you are capturing the construct of trust, and you have asked two questions. One is that, are you careful in terms of talking with others? Another question you are asking, like, generally do you trust other person? If somebody gives 5 out of 5 for first, 5 out of 5 for second, that indicate that it will be having high level of multicollinearity. 4 or 5 it is fine, but if you are giving, if almost all the respondents are giving 5 for both the options, that indicate that both the statements are highly high multicollinearity is present. So multicollinearity is basically where there is a very strong relationship between two statements. There has to be a relationship up to 0.9, it is fine. I mean, if it is going beyond 0.9, then there is a signal of multicollinearity is there, and we have some cutoff is there. So there's VIF value will be there, and that VIF value should be less than 10. If it is less than 10, then there is no issue of multicollinearity. And there is also one more concept called autocorrelation, which also needs to be avoided. So basically, this autocorrelation concept is very relevant in time series data. What is this autocorrelation is all about? Let's say, for example, if you are considering a month, okay, if you're considering temperature of say Bangalore, beginning of the month, okay, you might find that the temperature might be a bit cold, and end of the month you might find that the temperature might be a bit hot, especially if we are getting into summer from winter. So beginning of the month, when you're talking about the first and second day of the month, we'll be having almost closer temperature. The last day of the month, the temperature will be little bit different. There will be increase in temperature. The first 2 days of the month, where the temperature is almost same or similar, would lead to something called autocorrelation. Basically, you can perform this autocorrelation test the moment when you're using the time series data, but nevertheless, there's an option in linear regression wherein you can check and you can perform this autocorrelation test also, right? So basically, for this linear regression, we need to perform all these 5 assumptions. So once we are done with these assumptions, then we can do this SPSS analysis, right? So any doubt on this? Can we go ahead? Can we perform this test in SPSS? Have you got some clarity on these assumptions? Anybody is having any doubt on these assumptions? I think we all are behaving like our students, right? Anybody is having any doubt, or can we go ahead for SPSS?
Sir, will you tell me the third one, sir?
Third one. So third one, sir, you will be able to visualize properly using scatter plot. The concept is, okay, I'll give you an example. Okay, let's say that you are actually studying the income and spending pattern, right, sir? Income and spending pattern. So we found that higher the income, higher is the spending pattern. All right. And but upon further analysis, you found that lower income people who are having less income, their spending is less. But when it comes to people who are having high income, some people they spend more, but some people they do spend less. Overall, as the income increases, spending increases. But there is a difference in the trend even among the rich people also. That is what we call it as homoscedasticity, and that can be easily captured using error term. So whenever we are running this linear regression, as I have told you that error term is basically something which is unexplained, which cannot be explained, which we call it as an error term. Because y is equal to indicate that whatever value which is coming towards the right hand side, it should be in a position to predict y. It could be intercept, x, but apart from this, certain things can't be explained. That is what we call it as error term. So when you are having such kind of situation, the error term will be different for rich people and it will be different for small people, low income class. That is what we call it as homoscedastic. That means the variation of the error term will not be same. Okay, I'll give you another example. Let us say that in general, who is taller, sir? Men or women? In general.
Men.
Men. So let us say that you are comparing, impact of gender on height. Okay, impact of gender on height, and you have found out, you're comparing some Indian men. Okay, Indian men, and you found out that this gender is having an impact on this height, and you found out that generally male or taller than female. But in that female, there are few women who are from African countries who are naturally very, very tall. They are also in the sample. So you have some 10 male and 10 female. Among 10 female, 4 of them are from Africa. Okay, their characteristics might be similar to male in terms of height. So what happens is that the difference in the height will be more among female compared to the difference in height among men. Do you agree with this, sir? Do you agree with this? If there are few African women in a sample of Indian women, don't you think so? The difference in height, I'm talking about the standard deviation, the variation will be more in women, no, compared to men. Correct. Now that is what we call it as homoscedasticity. Are you getting, sir?
Sir, will you compare the price and demand?
Price and
demand, quantity demand.
okay, you want me to compare with price and demand to check out is there any homoscedasticity is there or not? Is that what you're asking, sir?
Yes, sir. Yes, sir.
Right. So let us say that lower the price, higher is the demand. Right now, sir, according to law of demand. Higher the price, lower is the demand. Right. Now let us say that I'll give you an example. Let's say that there are some exceptions are there for these goods. Okay. Of course, this is a general rule. Let me talk about goods like salt. So salt, let's say that the government of India is reducing the price of salt. Do you think so that we will add 1 scoop of salt extra in our dish just because the government of India has reduced the tax rate for salt and the salt has come down from 20 kg to 15 kg, 20 rupees to 15 rupees? Do we do that? Of course, no. Reverse. Let us say that the government of India has increased the tax of salt. Okay, because of which 20 rupees salt has become 25 rupees. Are we going to reduce 1 scoop of salt? No. So that means the relationship between price and demand holds true only for certain goods. If you're taking some 3 or 4 goods where one of the goods is salt, another goods is say rice, then this one, the characteristics of the rice will not fit into the characteristics of this this salt according to this particular thing. This can be easily captured through a scatter plot. I'm sure that I will be able to explain you more mathematically when we are doing the SPSS. Right now, this is the concept. So understand that when we are comparing across different groups, if there is a variation within one group, the variance of error term will be there. That's what I'm trying to compare, sir. You got it, sir? It's all about how how there is differences there within different groups. I'll show you very clearly when we are running the SPSS. Right now, this is the concept. The concept says that this is the variance of the error term, and this occurs because of this reason. That's what I'm telling you. The variance of error term occurs because of this reason, because of this characteristics. Okay, right. So can we go ahead, sir? Any other doubt? Any other doubt? Sir, is it clear?
No, sir.
60% something? Because we will be able to demonstrate or we'll be able to prove it, the concept of homoscedasticity only through the scatter plot. That time you can ask more doubt on it. Okay. How to identify? First thing is that how to identify whether my data is homoscedastic or not. That is more important. Okay. Yeah. All right. So now let us get into SPSS. Have you all downloaded this Nifty 50 data like how I did? Or you want me to share this so that you can work along with me?
Sir, share me, sir.
Sir? You want me to share it, sir, or you can, or you have already done, or you have already downloaded it and you have imported the, sir? You haven't downloaded it?
Sir.
You want to share it? Okay, fine.
Oh, no, sir.
Yes, sir. Tell me,
You
sir.
will be shared.
You want me to share it?
Yes, sir.
Okay, right. Just give me a moment, sir. 1 minute, 1 minute. Because for some reason my mobile and laptop, it is not getting connected with okay. Nifty data. Okay, now I will share this file with everyone. Just give me a minute. Just give me 1 minute. So I have actually I'm actually sharing the SPSS. Okay. Right. So I have
Sir, one more thing,
shared.
sir.
Sir, tell me, sir.
Sir, regression is the one of the type is linear regression.
Sorry, sir.
Regression is one of the type is linear regression.
Yes, sir. Yes, sir. There are several types of regression. Is there? Logistic regression is there. Okay. Now, to our session, we are focusing mainly on the linear regression. In that, we are going to focus on simple linear regression and multiple linear regression. Okay. Polynomial type is there. Logistic regression is there. Stepwise is there. So many different types of it. It's a big ocean, sir. Okay. You need to have a separate workshop for regression alone. Okay. That much big it is. But for normal people who are a beginner in research, you can start up with simple linear regression, multiple linear regression. Maybe you can try with stepwise linear regression. That is more than sufficient, which can fetch your need. Right. So I have shared the data of SPSS,
Sir,
the
sir,
one
one
which I
more, sir.
downloaded.
Sir, simply
Sir,
you
tell me,
have to
sir.
tell what is mean by regression, sir.
Sir,
In simple terms, what is mean by regression?
so logistic regression, basically the dependent variable is
Sir,
in
sir, sir.
the category.
I'm asking,
Sir,
I'm asking, I'm asking what is mean by regression in simple terms.
sir, regression is basically you are predicting. That is what it is all because regression. So predicting, it is all about prediction. Regression is all about prediction. But that is why we have something like y. This prediction is what we call it as regression. You can replace it with prediction. It is actually, we are trying to find out the mean, and through that mean we are trying to predict the dependent variable. And this prediction is independent on this independent variable, intercept, error term. So regression is basically about prediction using the mean, right? Yeah. So let us, I think, if you could open this data, I've already shared SPSS file that we are going to use it today, which I have downloaded it from Nifty 50. If you could open the data, then it becomes easy for us to analyze. Have you received it? Have you all received it, sir?
Yes, yes, sir.
Yeah. Please open it in your laptop. Is everybody
Sure,
in this? Yes, done, sir. Ready?
simultaneously you have done.
Sorry, sir.
Job, sir.
Are we ready, sir?
Yes, sir.
Ready. Okay. Ma'am, are we ready? 2, 3 people are actually Parul Rana, Navpreet. Have you received the file that I have shared, ma'am, in WhatsApp? Have you opened it in your laptop with SPSS installed in it? Yes. Okay. Right. So now it's very simple. refer the PPT. Okay, there are some 5 assumptions that I have mentioned, and I have also mentioned what type of test that we need to do that in SPSS, through which you can prove those assumptions. First assumption is the linearity of the model. What is the linearity of the model? It is, I wanted to find out whether y and x1 and y and x2, are they moving in the same direction? Are they moving in the opposite direction? Okay, there has to be some relationship between y and x1 and y and x2, and that relationship should be linear in nature. It should not be parabolic in nature, or there should not be no relationship. That condition should not occur. That is what we call it as linearity of the model. Okay, how do we check the linearity of the model? We can check the linearity of the model using scatter plot. Okay, for that, go to graph. Please follow along with me. Legacy dialogues, graph, legacy dialogues. Go to scatter / dot option. Okay, go to simple scatter. Go to simple scatter. Right. I wanted to check whether this bring previous day closing bring towards x-axis and next day opening bring towards y-axis. Previous day closing bring it towards x-axis, next day opening price bring towards y-axis. Titles, no need to mention, leave it. Click on OK. Right, now bring it down. You can see that the previous day closing price, which I have plotted in x-axis, and next day opening price, you can see that as previous day closing price increases, the next day opening price also increases. Now, how do I check it out? Double click. It will take you to a window where there will be a small option where you can fit the line. If the line is from the bottom left going towards the top right, it indicates that it is positively related. If the line is from top left to the bottom right, it indicates that it is negative relationship. If we are not able to draw any line and if the dots are scattered, it indicates that there is no relationship. Let's see how the line comes. You can see that the line moves from bottom left to bottom right, which indicate that there is a linear relationship between previous day closing price and next day opening price. Now, it's not over, because right now we have checked the linearity of the model only with respect to previous day closing price and next day opening price. We also need to check out the linearity of the model with respect to previous day opening price, that is x2, and next day opening price. Right, for that, go to the same option, graphs, legacy dialogues. Okay, scatter dot, go for simple scatter. In this, remove x1 and bring x2. Click on OK. Bring it down. Okay, here also you can see that the dots, it's not too much scattered, but it is following once again a positive relationship, right? So now we can comfortably say that it is actually fulfilling the first assumption. There is also one more way of doing, if at all if you are having too many independent variables, you need not to do that for each and every independent variable and dependent variable. For this, you can use the matrix, same graphs, legacy dialogues, all right, scatter dot, choose the matrix here. Okay, choose the matrix here, next day opening price. Okay, to bring all the options towards here and click on OK. Right, here you can see that, okay, here you can see that there is a graph which they have plotted between. So consider only these two things. Okay, so instead of we doing it individually, also you can put it here. consider only these two graphs because this one, these two graphs. Wait, this one and this one. This is on Y, that is next day opening price. This is previous day closing price X1, previous day opening price X2. Both these graphs you have to consider. The other graphs you can delete it. Doesn't you don't need to consider it. Okay. So this scatter plot in the form of matrix, it gives us one shot. You only have to do that separately. So whether you use a scatter plot, simple scatter plot, or whether you are using it in a matrix, the takeaway is very simple, that there is a linear relationship between dependent variable and independent variable. Are we clear on this? Anybody is having any doubt on this? Anybody is having any doubt? Are you able to follow along with me? Have you done the steps along with me?
Sir, tell me the path.
Which one, sir?
Tell me the path.
Dependent and independent
pathway.
No, sir. Can you please repeat it, sir?
Path, sir. PATH, path.
Tell me the path. Okay. It's very simple, sir. I'll 1 minute. You are on this page, right? Sorry. You are in this page where you have opened the data that I have shared. You are on this page. Top of the page, you have this binocular symbol is there. Above that, you have this graph is there. Go to graph.
Yes, sir.
Graph. Choose this legacy dialogues. Okay. Choose scatter. Right now, you go with simple scatter. Okay. With simple scatter also, you can prove the linear relationship. The concept is more important. What technique you use doesn't matter. Choose simple scatter. Okay. In the y-axis, now by default, it will be towards the left-hand box. Now, what is y here? Y here is next day opening price. What is the x? You can choose 1 by. You can choose x1 and bring it towards x-axis and click on OK. You will get this chart. Once you're getting this, double click and there is a small icon is there. Add fit line and total. Choose that, you will get a line which indicate that there is a positive relationship between x and y. Do the same one for x2 also. Is it clear, sir? Is it clear? Try doing it at your level. If it is clear, we can go to the next assumption. Sir, can we go to the next assumption, sir? Are you able to get the output?
Yes, sir. The last one is not come.
No. Are you able to get at least this one?
Yes, sir.
Fine. Try doing it because you will be able to find this recorded lecture also. You can try doing it in case if you have skipped. But the concept is more important. Okay. Path, even if you miss, absolutely not a problem. You can refer it through the recorded lecture. Concept is more important. Second one is that normality of the residuals. Okay. What do you mean the term normality of the residuals? This error term, no? This error term should be normally distributed. This error term will be there for each and every value, and that error term should be normally distributed. Remember, in correlation, we did not talk anything about residuals. We talked about normality of the variables. Here it is about normality of the residuals. There are a few ways that we can do that. One way is that normal PP plot, and the other way is that Shapiro's milk test, through which you can test the normality of residuals. So for this, please pay attention for this. Okay, now we are going to perform a linear regression test, and as an output, we will be getting the normal PP plot, through which we will be in a position to say whether the data is normal or not. Okay, click on analyze. Please work along with me. We are going to perform the linear regression test, and there are a few options. If I check those options, I will be able to see the output through which I can also confirm the assumptions. So please click on Analyze, the top window. Okay, have you clicked on it? All right. Then you will find an option called regression. You'll be able to find an option called regression. Then click on linear. Okay, these are all different types of regression. I'm not going to explain all these types. You can try it at your level. Right now, we are going to focus the most popular type of regression, which is a linear regression. Choose linear. By default, we will find all the variables, all the 3 variables which is under study towards the left hand side. Now, what is the dependent variable here? Dependent variable is next day opening price. Bring it towards the dependent variable side. What are all the independent variables? Independent variables are previous day opening price and previous day closing price. Bring it down towards the independence box. Now, are you able to follow till here? Are we in the same page? Are we in the same page, sir? Right? Now, click on statistics. Click on statistics. There will be an option called Durbin-Watson. There will be an option called Durbin-Watson. Choose that option. Okay. You can also choose descriptive. Okay. So that you will get mean, median, all those data you will get it. In the first, you choose Durbin-Watson, which will be useful for testing the autocorrelation. And then you choose descriptive and click on continue. Then you go to the second button called plots. Second button called plots. Yes, somebody is telling something? Yes, yes, ma'am. I'm not able to hear. Yeah, tell me, ma'am.
Sir, previous path will tell me, sir.
Okay. Go to statistics.
Go to statistics after.
Yeah. Choose Durbin-Watson and descriptives. Okay, that's it.
Okay, sir.
Click on continue. Done. Then go to the second button, which is plots. In plots, this is extremely very much important, because through this only we will be able to figure out whether the residuals are normally distributed or not. Now here I am not talking about the normality of the variable, I am talking about the normality of the residuals between independent variable 1 and dependent variable, between independent variable 2 and the dependent variable. For that, do you find some wordings like Z, pred, Z, resid? Are you able to find it, sir?
Resid, yes, sir.
Yes. Choose this Z, okay, pred, okay, that is the predictor, Z predictor towards the x-axis. So basically, independent variable can also be called as a predictor variable, okay, and this Z pred indicate that that is the standardized prediction, right? And there's Z resid is there, no, which is nothing but the standardized residuals, Z score of the residuals. Bring it towards the wall. Don't interchange it. It is better to follow the same pattern, universal, which is always good. Now, I've also already mentioned in the PPT that if at all you wanted to find out the normality of the residuals, you can do that through normal PP plot that I have already mentioned it. So for that reason,
P is greater than 0.05.
Sorry, sir.
P is greater than 0.05.
Yeah.
Predictor is.
Yeah. So choose this normal probability plot, because through which we will be able to conclude a conclusion that whether the residuals are normal or not. Histogram also not required. Okay, this is sufficient. Then go to save. Go to save. Probably you can choose this standardized, okay, unstandardized, unstandardized, this standardized, and this one. This one you can choose, okay. Choose these options: unstandardized, standardized, okay. Residuals, there's unstandardized, unstandardized, okay. Click on continue, okay. Then no need to choose anything. Bootstrap, you can ignore it. So only these options we are choosing. In statistics, we are choosing descriptives and Durbin Watson. In plots, we are choosing,
Sir, one more
ma'am?
step. In my area, I have given the style, save, options, style, bootstrap.
Yes, sir.
In my SPSS, in statistics, plots, save, options, and style also have to give it.
Now there may be some difference in case, see, right now what I'm using is version 20. Probably you might have downloaded the latest version, which may be version 25. So some slight difference is there. There's nothing wrong in checking some of the options, but right now don't go for bootstrap. Okay, choose the bootstrap option. If you are choosing any other option, it is fine. That's not a problem. But plots, ensure that you are having this normal PV plot, that is normal probability plot. This option has to be checked. Okay, and X should have Z credit score and Z residual. Other things, even if you're choosing one or two options, that is fine, not a problem. We can choose those relevant output, whichever you want, right? So once we have done that, click on OK. Click on OK, and this is the output you will get. Okay, this is the output you will get, and let us analyze this output. Now, this is the regression output, what I have got. Okay, and this is the descriptive statistics, which talks about the mean, standard deviation, number of sample, and all those things. This is the correlation matrix that I have got, which talks about how the variables are interrelated with each other. All right, and then this is the kind of regression testing that I have used. That is the principal testing. Now, I'm very much interested in check out whether my data is normal or not. For that, I need to refer the normal PP plot. Where is the normal PP plot? Yes, here it is. So now this is the normal PP plot. So what does it says? The theory says that if the dots are falling approximately close to the line, it indicate that the residuals are normally distributed. Are you getting, sir, what I'm saying? If the dots, okay, the dots are approximately falling on or very much near to the line, if it is falling almost near to the line, which indicate that the residuals are normal. So based on this graph, can you say that the residuals are normally distributed or not? What is your conclusion, sir? What do you say based on this? Are the dots are falling on the line? I mean approximately. Are the dots are falling on the line? Majority of the dots? Yes or no? Look at the screen, sir. We are actually analyzing normal PP plot, right? So it is falling, which indicate that it has fulfilled the second assumption also, which is the normality of the residuals. Okay, normality of the residuals. This is one way of me finding out the normality of the residuals. There is also another way is there, which we call it as a Shapiro's will test. How do we check it out? Is that here you find this residual is there. No, this is the standardized residuals, and this is the Z rest is the standardized Z score of the residual. This is the unstandardized residuals. Standardized residuals and unstandardized residuals. Now, what does it says? It says that normality of the residuals. Now I have got the value of residuals, both in its standardized form and unstandardized form. I can check the normality of these variables. Already I have done it through normal PP plot, through which you will get some idea that it should be normally distributed because the dots are perfectly falling on the line. But then you wanted to confirm. How do we confirm it? Okay, through these options. Now you may be wondering that how did I get this option? I got this option because while I was performing this linear regression test, in the save button, I have chosen these predicted value, unstandardized, standardized, residuals, unstandardized, and standardized. If it is unstandardized, that Z value will not be there. If it is standardized, Z value will be there. Right? Now I'm going to check whether both this standardized and unstandardized error is normal or not. How do I check it out? Go to Analyze, Descriptive Statistics, and Explore. Analyze, Descriptive Statistics, Explore. Here, I'm actually interested in choosing the unstandardized residuals and standardized residuals. Bring both these variables towards the dependent list. Bring both these variables towards the dependent list, right? Click on OK. Right. Once you have done that, straight away go to Shapiro's Wilk test. Look out, where do you find this Shapiro's Wilk test? Just give me a moment. Look out for Shapiro's Wilk test. If the p-value is above 0.05 for Shapiro's Wilk test, that indicate that, okay, now for some reason I have not chosen it. I'll redo the test one more time. Okay, by choosing the Shapiro's Wilk test. Descriptive, explore, okay, options, plots, okay, normal plot with test. Okay, this was the option which I should have chosen, which I didn't choose. That's why I didn't get the necessary output which I need to have. Okay, right. Explore, unstandardized, standardized. Yes, this is what the output that I'm actually looking for. This table, okay, test of normality table. Look out for Shapiro-Wilk test. If the significant value is above 0.05, it shows that the data is normal. Why? Because null hypothesis indicate that the data is normal. If the significant value is lesser than 0.05, we reject the null hypothesis. If it is above 0.05, we accept the null hypothesis. That means we fail to reject the null hypothesis. So we accept the null hypothesis, which indicate that the normality of the residual is present. That means the residuals are normal, whether it is a standardized one or unstandardized one, that doesn't matter. So now there are two ways that you can check the normality of residuals. One way is that through normal PP plot that I have shown you, where this one, through normal PP plot that I have already shown you, okay, where the dot should fall on the line. The second way is that you have to go to Analyze, Descriptive, Explore, and choose those unstandardized residuals and standardized residuals, and look out for Shapiro's Wilk test. And if the significant value is above 0.05, it indicates that the residuals are normally distributed. Is it clear? Is it clear, sir? Sir or ma'am? Is it clear? Anybody is having any doubt? Anybody would like to repeat any concept? So right now we have performed two assumptions of linear regression. First one is that linearity of the model. Second one is that whether the residuals are normal or not. Both the assumptions have been fulfilled. Is it clear for everyone? Anybody is having any doubt? Please feel free to ask because it's a training session. Yes, please. Yeah, anybody is having any doubt?
So in the second assumption, you have to see p is greater than 0. something.
Yes. Second assumption I have mentioned that the p-value, that is a significant value. Significant value should be above 0.05. So in our case, the significant value is 0.878, which is much above 0.05. It signifies that the data is normal.
Okay, sure.
Fine. Any of
Yes,
these
sir.
two methods, if you're not comfortable with this table, if you're okay with the normal PP plot, no problem. Just the concept is important. That's what I'm saying. The concept is important. You use this method or that method, or you use a simple box plot. The choice is yours. Concept is important. That means normality of the residual is the assumption of linear regression that I have done it, reported with these findings. Okay. So once you have done that, the third assumption, this is where the doubt which you have asked now, it is coming, where homoscedasticity, that means the variance of error terms are similar across the values of independent variable. That means when you are plotting the graph between the residual and predictor, okay, this being residual, that means the error term, okay, across the independent variable, it should vary. So I'll show you how we have to check it out. So because already we have done the analysis, I'm rerunning the model, okay, so that we'll get the. So this is already I have chosen all those things. Darwin Watson I have chosen, plots, everything I have done it. So I'm just rerunning the model. If you're able to scroll up, you can also find the output. I'm just for your understanding, I'm doing it one more time. All right. So in this I'm actually bringing it down. All right. Okay. Normal PP plot, which I've already given the interpretation. Okay. Now here it is. Okay. This is the data which I want you to have a look at it. Through this graph, through this scatter plot only, I'll be in a position to establish that my data is fulfills the assumptions of homoscedasticity, or is it following the heteroscedasticity? So basically, what I have done here is that I have plotted a graph between standardized predicted value and standardized residuals. Now, if I fit a line, okay, if I fit a line, the condition for homoscedasticity is the dots, okay, the dots should vary in uniform. That means here there is a dot, here also there is a dot. Here there is a dot, here also there is a dot. Here there is a dot, here also there is. It's not that the dots are located only towards the left hand side or only towards the right hand side, or only it is cluttered towards a particular side. This is what we call it as homoscedasticity. If the dots are located equally across the line that I have drawn, which if you're able to form a kind of cylindrical in structure or conical in structure, which indicate that the data fulfills the assumption of homoscedasticity. Is it clear, sir? You are asking this doubt, no? Sir, you are asking this doubt, right? How do we identify homoscedasticity? This is how we need to identify the homoscedasticity. And how did we get this output? We got this output because we chose that option. What was the option? When we have done this test, when this analyze regression, okay, analyze regression linear, and then in the options, okay, sorry, not in the options, in the plots, I have chosen this. Sorry. Yeah, the plots. Okay, I have chosen this. For that reason, I got this output. Okay. So now by default, you'll be getting this output. Okay. Only thing is that how do we say that it is homoscedastic? It is if the dots are located equally, okay, across the line. Okay, here there is a dot, here also there is a dot, here there is a dot, here also there is a dot, which indicate that the error terms are varying in constant. It is not that it is having more variance for one independent variable and less variance for another variable. Okay, this is what the concept of homoscedasticity is all about. And then The fourth one is very simple, multicollinearity. Already I have told you multicollinearity is about interrelationship between the statement. It should not be how to draw a line. It's just double click and there is a line of best fit. It will come. Double click here. At the top, you will find this one, add fit line at the total. Choose that. Automatically, you will get a line. Okay, now this is a different one altogether. Okay, that automatically you will get a line. The first one is more important. Okay, not this one. Sorry, it got cluttered. I'll delete this. Not this one. The first line. First, you will get a proper line. Okay. Wait. Just double click and choose the line of best fit. You will get that line. That's how you need to. Somewhere I need to rerun this model to get the output. Otherwise, I can take it out. Top also. Yes, I'll show you through this. Okay, this is one which I wanted to show. You asked. Okay, leave it. So now the fourth one is that multicollinearity. Multicollinearity, how do I identify? The VIF should be less than 10. Look out for multicollinearity, anywhere is it been mentioned? Multicollinearity. Let me check. Did we choose this option or not? Otherwise, we'll rerun the model. Not a big deal. Regression, linear, and let us check whether have we chosen this. Collinearity diagnostics is there. No, choose that option. Okay, collinearity diagnostics. Click on OK. Okay, right. So, okay, in collinearity diagnostics, I think we'll be able to find the multicollinearity. Yes, collinearity statistics is there. No, here it is. Okay, so this one you can take out. This is very important. Okay. I'm opening Word so that I can paste this. It's very lengthy. This is. Layout, I will change it to landscape. Orientation. Landscape. I will paste this. All right. Now you can see that the VIF value is 6.293. VIF value is 6.293. Okay, what does the rule says? The rule says that if VIF value is lesser than 10, it indicates that there is no multicollinearity. And the last one is that no autocorrelation. How do we have to check it out? There is a test called Durbin-Watson test is there. If your value is from 1.5 to 2.5, it indicates that there is no autocorrelation. Now for that, I can go ahead and check the Spss output and look out for the autocorrelation value. Check autocorrelation, Durbin-Watson test. I think I have chosen that option. If not, we have to rerun the regression by choose yes. Here we go. Look out for 2.239. So I will copy paste this also. You can see that the Durbin-Watson value is 2.239, which indicate that no auto correlation. So this is the proof. No auto correlation because our Durbin-Watson value is between 1.5 to 2.5. Okay, if it is less than 1.5, it is positive. It is above 2.5, it is negative. Here also VIF is less than 10. Okay, which indicate that it is not having any multicollinearity. Okay, here it is. There we go. Okay, autocorrelation. Okay, so no autocorrelation. All right. No multicollinearity. Okay. No multicollinearity. These are all some of the tests of the output that I have got. And how did I test? How did I test about linearity of the model through scatter plot? So for all those things, you can take out the data output from Spss and you can put it in the word and you can explain it. Homoscedasticity, how did we test? Homoscedasticity we tested through this one. So you can go for this, double click, and you can add the fit line here. Okay, all right. You can copy the chart and you can paste it over here by mentioning the homoscedasticity, and you can give your interpretation also. Okay, that also it has been fulfilled. And then what is the other assumption? Normality of residuals. That is normal PP plot. Normal PP plot, where it is normal PP plot. This is the one. Copy this. Normality of residuals. This is normal PP plot. This is also fulfilled. And what is the other one? The other one, the last one, is that linearity of the model. How did we check the linearity of the model? Through the scatter plot. This is how it is. Linearity of the model. Linearity of the model. Linearity of the model. This and this. Linearity of the model. Right? So what I will do is, these are all the outputs that we have got for this, which I will SPSS output for multiple linear regression assumptions. Okay, so now this I will save it. Okay, and I will share this to you in our WhatsApp group, so that all right. Okay, now ResearchBrains. Okay, save it, and I will send it to through this WhatsApp also. Okay. So till now, any doubt? Anybody is having any doubt? Anybody is having any doubt? How to draw the line? Okay, right. So what I will do is, because just for your reference, I'm actually sharing the Word file where I have saved the critical outputs that we have discussed, so that in case if you are having any doubt, you can have a look at it. 1 minute, 1 minute. Okay, SPSS output. So I'm sharing the SPSS output for multiple linear regression assumptions. All the assumptions, I'm sharing the output, and you will also be getting this recorded link so that you can refer it. And actually, it is downloading it. Just give me a moment. So once it has been downloaded, then automatically I'll share this output to you in the WhatsApp group. Right. So meanwhile, anybody is having any doubt? Anybody is having any doubt? Any specific doubt? Anyone is having? On linear regression, have you got confident that I'll be in a position to perform the assumptions of linear regression? So if you're doing it for the first time, probably you may feel it a bit difficult. But when you talk about other tests, if you're clear with the assumptions, because these assumptions are somewhere linked with the assumptions of parametric tests. So no matter whatever test that you are doing, it becomes very easy for you, believe me. Yeah. So anybody having any doubt, you can check it out with me. If not, then we can wind up the session. So I will share this output to you. Yes, here we go. Yes. So if there is no doubt, then we can close today's 4-day session. Yeah. Okay, Raja sir. Raja sir, are you there? Okay. Fine. So tomorrow we will use the same data. I think already I have shared the data with you, and I have also shared the SPSS output for multiple linear regression. So it fulfills all the assumptions. So tomorrow we will study the we will do the multiple linear regressions, and we will study the interpretation of it. Right? Yes. Yeah, Raja sir, anything?
Sir, one more, sir.
Yes.
Sir, we have to take in from a previous day closing is x1. Previous day opening is x2.
Yes.
Sir, why you have to take in that one is x2, this one is x1? How will you consider?
Anything, sir. We can use you can give x2 for previous day closing and x1 for next day closing, because right now we have not got into regression at all. We have done only the testing, assumption testing, to check out whether I can do multiple linear regression with this data or not. For this, I have done all the 5 assumptions, and it is fulfilling all those assumptions. Even if you are not using x1, x2, that doesn't matter, because I wanted to study which is having a higher predictive power of, see, I wanted to know what is the opening price of stock market today. I'm confused whether it is dependent on today's closing price or today's opening price. That is what I wanted to figure out through this analysis. Let's see that which is having more impact. Today's closing price is having more impact, or today's opening price is having more impact on next day opening price. This is what I'm actually studying it through regression. X1 my own, for my reference, what I have kept. If you wanted to use some other name, that is also okay.
Sure, sir. Thank
yes,
you.
Sir. Thank you, sir. Thank you, sir. So meet tomorrow. So once again, please attend the session along with your laptop and SPSS. Then only you will be able to work out the problems along. Yeah. Thank you.